Hello and welcome back everyone. My name is Akriti and today I'm here to solve one more question of Leetcode. So this is our today's daily problem of Leetcode. So let's get started. So this is a question number 1404. Number of steps to reduce a number in a binary representation to 1. Right. So this is our today's question. Let's read the question first. So it is given in the question that we are given a binary representation of an integer as a string. Okay. So we have to return the number of steps we require to reduce it to 1 under the following rules. Rule number 1 is if the current number is even, then we have to divide it by 2, right? And if the current number is odd, then you have to add 1 to it. So this is our rule which we will be using in our question. So let's read some examples. As you can see here, this is 1101, which is a 13 in decimal. So if as we read earlier, if a number is odd, then what we have to do? We have to add 1 to the number. So if here my number is 13, which is odd, so I will add 1 to it. So my number will become 14. Now if my number become even, then I have to divide it by 2. So on dividing the 14 by 2, we will get 7, which is again odd. So now my number is also, I will again add 1 to it. So my number will become 8 and again I will divide it by 2 and I will continue it until I reach 1. So in how many steps I will reach 1? This is the requirement of our question, right? So this is something we have to figure out. This is example number 2 where I am given 10 which is corresponding to decimal 2. Now as my number is even, so I will simply divide it by 2 and on dividing it by 2 in one step only I will get 1. So my answer is 1. So this is something we have to do. Now let's figure out the very basic thing which will came to your mind after seeing this question will be like, yeah, let us just convert this binary representation into a decimal and simply perform the operations, right? This is something you will think for the very first time. So on converting, yeah, I can say we can do this. We can simply convert like as we are given 001101. So on converting in decimal, we will get 13. Very fine. After getting 13, you will say, yeah, we can perform the operations now. Currently, our 13 is odd, so we will just add 1 and then we will divide 2. And this will be the most simple solution you can get. But let us see the constraint over here. The constraints are the length of the strings can be around 500. So you just think if the length of the string is around 500, then my number will be beyond the range of integer or even beyond the range of long term, right? So basically my number is too large, so you cannot convert my this much large number into a decimal or something. So we have to play with the strings only. This is something we need to observe here. So yeah, let's do this without changing it into the decimal. So simply what I will do, so first of all, let me explain you some concepts of the bit manipulation if you are not aware of them. So the very first concept which I'm going to use is, suppose I'm given a binary representation of any decimal number. Let us suppose this is 1101. Now if I need to figure out whether this number is odd or even in decimal, then simply what I have to do, I have to check the rightmost bit of the binary, which is here 1, right? I just have to check the rightmost bit. If my rightmost bit is 1, then my number is odd, and if my rightmost bit is 0, then my number will be even. So let me write it here. This is the rule, concept number 1 which we are going to do. If my rightmost bit is 0, then the number will be even, right? And if the rightmost bit is 1, then your number will be odd. So this is the first concept which we are going to do. Now let's observe how we will perform the addition and division operation in a binary number. So simply you must have known this, that if you want to divide a binary number by 2, then you only have to perform the right shape operation, right? this is the sign for the right shift operator. And if you are right shifting any number, suppose my number is n, right? So if your number is n and you are right shifting my number by 1, then it will be like n by 2. So the division will happen automatically in the decimal format. Okay, so my this part is done. If I want to divide a number, then I will simply perform the right shift operation. Now what actually the right shifting mean? Let us understand this also. So suppose you have 1101. This is your number in binary, and you have to right shift this number by 1. By 1 means I am shifting my number toward the right by 1 place. Simply this means that. Okay. So in order to shift my number toward the right by 1 place, I will get something like um, this place will become empty. Okay. And here I will shift my number, so this will become 110. Okay. So this will be the main simple the right shift operation. Okay. So now as you can see, here is an empty place. So in place of this empty, you can simply fill 0. No, nothing, no issues here, right? So if you have any empty place, you can fill 0 in place of that. So this is my right shift operation. So suppose if you have a string and you want to perform a right shift operation in my string, then what will you do? Simply you will pop the rightmost bit from the string. This will be your right shift operation in a very simple terms. Okay, so we are done with this. Now in order to perform the addition of 1 in any binary number, what I will do? Suppose I have 1101 this number, and I want to add 1 in this binary number. So what I will do, simple, I will just start from the rightmost position, which is 1 here, and I will check if it is 1 or if it is 0. Suppose it is 0, then I will simply add my 1 to this number. This will become 1, and I will just return my string. That's it. Now suppose if it is 1, then I will add 1 to it. So you must know the 1 plus 1 in the binary is 0 with a carry 1, right? So if you are adding 1 to 1, you will get something like will be like 1 plus 1 is 0, and you have a carry 1 over here, right? So 1 plus 1 will be 0 and you have a carry 1, and now you will start with adding carries from the next place. You will check again if it is 0 or 1. If it is 0, then simply you will add 1 and just return. So this will be your final string. And if it is 1, again you will add 1 plus 1 equals 0, and you will be left with 1 more carry, right? So this will be the addition operation. And now suppose if you have a number like this and you are adding 1, so it will be like adding 1 plus 1 equals 0, and then again 1 plus 1 equals 0, and again 1 plus 1 equals 0 with a carry 1, and now you are finally left with a carry 1. So you will simply add it here. Okay, so this was the basic addition and the division operations which we will be doing in binary strings. So let's start with it. So the very simple solution will be like, I will keep on performing operations while my strings is not equal to 1, right? So I will keep on performing operation. I will check if it is odd or even. So what was the trick of checking if it is odd or even? We will check the rightmost bit. Okay. So the rightmost bit is s dot length minus 1. Yeah, this will be our rightmost bit. Okay. So if it is equal to 0, then yeah, this is our even number. Then what you had to do, you had to only perform the right shift operation. And what actually the right shift operation is, just pop the rightmost bit from the string, right? So simply pop back. Else if that particular bit is odd, then I had to add 1. So yeah, this is something we had to do. That's it. And after doing all this, I will increase my number of steps by 1. Here let's make a steps variable. Steps equals 0 initially, and then simply I will return steps. Okay, so let us make this add 1 function here. So in my add one function, this will be my void type. I will take strings by reference, and I will make changes in that particular strings only. Yeah, so I'm done with this. Now I have a strings, and I will start from the last. For yeah. So yeah, I'm starting from the rightmost bit, and I will keep on checking if it is 1 or 0. If it is 0, I will simply add and break from the loop, and if it is 1, I will keep on adding and moving the carry to the next bit, right? This was our approach. So yeah, let's start. So I will check if as the length from str of str dot length minus 1. If this is 0, then I will just make it 1 and return. As simple as that. And if it is equal to 1, I will just make it 0. Oh, sorry. Yeah. I will make it 0 and keep on moving. Okay. So this was our full approach. Now I think I'm done. Yeah. At last, I have to check if I'm left with a carry or not. So if I'm not returning, means it simply means that I am left with a carry. So I will simply do this. Strings will be 1 plus that particular strings, because we are by adding 1 in the starting, right? So this is, we are done with the question. Let's try to run it first. Um, Anything else? That's the plan. I should be less than. Anything goes wrong, I think. Let me check first. So for this, I should be less. Yeah, sorry. I should run the loop from the last only. I will start from s dot length minus 1. I will be greater than equal 0, and here I minus 1. Because we are starting from the rightmost bit, and we will keep adding 1 and that only. Please, you just, yeah, it's running fine. Let me submit it. Just a minute, I'll check. Update. If my string is 0, then I will make it 1 and return. If it is 1, then I will just make it 0. This is absolutely fine. Anything wrong here? Answer is 0. If it is not equal to 1, if 10 minus 1 equals 0, then I have to go back, otherwise I have to add one step. What's wrong with that? Everything is fine with this. Oh, sorry. This was the mistake. Which should be stranger. Not the work fine. Because if you are at a particular index, then you will check for that only, right? Give me some of this. Okay, so it's working fine. So yeah, guys, this was the whole solution of our problem. If you have any doubt, query related to the question, you can simply ask in comment box, and I will try to solve it out, right? So yeah, thank you so much. Bye bye. Have a nice day.